Good morning, students. Welcome back to online class. I'm Subhashini Mudaliar. Today we are going to study about metals and non-metals, part 4. In that, we are going to study about the ionic and covalent bonding, as well as occurrence of metals, reactivity series, extractions of metals of high reactivity. So for that, let's start with a new topic, that is about the ionic compound and the covalent compound. So what is ionic compound? When metal and non-metal combine to form a compound, that is the ionic compound. Ionic compound is basically what? Transfer of electron, that is donate or accept of the electron. Donating and accepting, that is how it forms a compound, is an ionic compound. And what is covalent compound? When the electron sharing its electron and forming the compound, and that is called covalent compound. So here they have taken an example of a sodium and chloride ion. Ion means what? What is sodium? Na. Element, it's an element. And sodium ion means what? When one electron is already donated. So Na, sodium ion means Na plus, and chloride ion means what? Cl minus. So sodium and chloride ion being oppositely charged, and that's why it is attracting and it forms NaCl, sodium chloride, and resulting in a formation of an electrovalent bond or ionic bond. So metal, this is a metal and this one is a non-metal. When metal and non-metal react with each other, it forms a ionic bond. And what is the another name of ionic bond? It's an electrovalent bond. Sodium chloride exists as aggregates of oppositely charged ion in a definite geometric shapes that you will study afterwards, not now. Such a bond formed by a give and take of electron is called ionic or electrovalent bond. Compounds formed in this manner by a transfer of electron. This word is important. Transfer of electron and give and take of electron, or you can write donate or accept of electron. These three things you can write. And that is called what? Ionic compound or electrovalent compound. Now what is a covalent compound? Sharing of electron. This is the more important word. Sharing of one or more pair of electron between the two combining atom is called covalent compound. Deeply you will study in the next chapter in the carbonates compound. Okay, so these are the properties of an ionic compound. So ionic compound are compounds and are solids and hard due to strong force of attraction. Strong force of attraction means what? It is a solid, so tightly packed, the molecules are tightly packed. So and the ion is a charge as a positive and the negative ion. So it's a, so they are solid and hard due to the strong force of attraction. The next point is they are generally brittle and break into pieces when pressure is applied. Obviously, when any pressure is applied, it will be break. Next point, ionic compound have high melting and boiling point, as considerable amount of energy is required to break the strong intermolecular force of attraction. Why? Because of the solid. If solid is there, so more energy is required, more heat is required for breaking. So they have high melting point. Next point, they are generally soluble in water and insoluble in solvent, such as kerosene, petrol, etc. This is quite, as you take an example of sodium chloride NaCl, it is soluble in water and insoluble in solvents such as kerosene, petrol, etc. These are all the properties of the ionic compound. The last point is what? Ionic compound is the solid state do not conduct electricity. As you take a salt, apply electricity, you can do that one at home. Just check whether the bulb is getting glow or not. As you can see, it does not conduct electricity. So solids, when it is dissolved in the water, at that time you apply the electrode inside, then it is a good conductor of electricity. So the conduction of electricity through a solution involves the movement of charged particles what is there inside the water then? If I am taking a salt in the water, so that salt, which is in a form of sodium chloride, when it is dissolved in the water, it is in the form of ion. Which ion? Cation and anion. So cation is positive charge and anion is negative charge. So just one thing you make note that cation, cation, cation is positive charge, and anion is negative charge. So cation attracts to cathode and anion attracts to anode. It's an electrode. This also we will study in next chapter. Anion attracts to anode. Anode, AODE, electrode. This both is an electron. So cathode is a negative electron and anode is a positive electron. This deeply we will study in the next chapter. Okay, understood? See here the properties of ionic compound. So what are the experiment is taken over here? This is the Bunsen burner, the fire, and spatula containing a sample of ionic compound. You can take any salt means sodium chloride, magnesium carbonate, calcium carbonate, anything you can take it over here. So you can see the different color, that is the color of the metal ion, cation. Here they have taken the salt in the solution form. That salt solution under the test, which is dissolved over here, and graphite is an electrode. This graphite act as both cathode as well as anode. So see here, this one is a positive electrode and this one is a negative electrode. So positive electrode means what? Anode, and this one is a negative electrode, so it means what? Cathode. So cathode attracts cation. So whatever salt is there, for example NaCl salt is there, NaCl salt is there, so which will go here in the form solution. Here it will go positive, maybe Na plus or H plus. So Na plus will not go. Sodium, for example, look at here, this is a solution of NaCl. NaCl plus water is there in the aqueous form, H2O. Here you are having a negative. Negative means what? Cathode. This is the cathode electron. And positive means what? It's a anode electron. Yeah, this one is a positive. So positive attracts negative. So negative, what is there? Just see here. This one is Na plus and this one is Cl minus. And here in the water, what is there? H plus and OH minus is there. Or you can write O, oxygen, O2 minus. Right? So which will go here in the positive anode form. Here you will get oxygen. Oxygen molecule you can collect over here, and here you will get water molecule. Or you can get over here chlorine. Chlorine also you can get. So what is remaining here? It is remaining NaOH. NaOH is remaining in the solution. This is what actually how it works, and you can see the bulb glow over here. Why? Because the solution is in the form of ionic solution. Salt is dissolved in the water. Fine. This is the properties of the ionic compound. Next one topic is occurrence of metal. How it looks. What is the occurrence of metal? How it looks. The most unreactive metal that is not affected by air or water, that is what? Silver, gold, platinum, which is generally found in a free or native state. That's why the rate of this all metal is high. It is expensive. It is rarely found in the ground. Most metals, however, are found in combined state in the form of their oxide ore, carbonate ore or sulfide ore. Can you give me the example of that one? Any ores, oxide ores like sulfur dioxide, carbon dioxide, yeah? Any even in the form of ore, carbon dioxide, sulfur dioxide is in the which form? Gaseous form. So ore means what? Hematite, bauxite. These are all ores. From the hematite, is extracted from the bauxite, Al2O3. Aluminum is extracted. That is what actually a ore. Okay. Now minerals, the naturally occurring compounds of metal along with the other impurities are known as minerals. What is a ore? Right now we have discussed what is a ore. The mineral form from which metals are extracted and profitably and conveniently are called ores. The next one is what? Gangue. Now, what is a gangue? Or ores containing a metal compound with some of the impurities. So, gangue contains some of the impurities, that is like soil, sand, rocky material, etc. So, these impurities are called what? Gangue. So, from the ore, whatever the impurities you are collecting, that is called gangue. Metallurgy. Now, what is metallurgy? Metals can be extracted from the ore by employing different separation technique. You know the separation technique, right? Like filtration, decantation, then fractional distillation, normal distillation. So these are all the techniques. Okay, so is used. The process used for the extractions of the metal in their pure form from their ore is called metallurgy. So these are the all reactivity series. This you have to learn. How you will learn? Potassium, sodium, calcium, magnesium. This is Mg, Mg total. Magnesium Mg, aluminium, zinc, iron, lead, copper. Hg is what? Mercury, Ag, silver, Au, gold. So highly reactive is what? Potassium is a highly reactive, and very least reactive is come down. So like platinum is also down. Silver, gold, platinum is all what? Very less reactive. This is the reactivity series. You can remember in that way. Please stop calling me zebra in library. Call me something else. You can write. So please, for P, what is potassium? Is a K. Right? Stop में क्या आएगा? S means what? Sodium. Calling means calcium. Me means magnesium. Letter come. Means what? Aluminum. Zebra means zinc. In matlab iron. Library, lead. Call me something else. Call me copper. And the last one, do you remember? Mercury, silver, gold. This is how you can learn. So the arrangement of metals in the decreasing order of the reactivity in the form of series, and that is called what? Reactivity series of the metals. So the first place is a potassium. It's a highly increasing high reactivity series. It is and the down one is a low reactivity series. So three categories of the metals: metals of high reactivity, metals of medium reactivity, and metals of low reactivity are there. Now the extractions of the metal, how you can extract the metal from its ore. So the process of obtaining metal from ore is called extractions of metal. The various processes involved in the extractions of metal is called metallurgy. The three major steps involved in purification of metals are what? Concentration of ore, conversion of ore, concentrated ore into metal, refining of impure metal. These are the three steps which is used for the purification of the metal. Again, concentration of a ore, conversion of a concentrated ore into metal, and the third one is the refining of a impure metal. So in the first one, concentration of a ore, what is that? How we will remove that one? The unwanted impurities present in the ore is called gangue. As you know, we have studied sand, soil, and other impurities are called gangue. By removing gangue, one gets a greater concentration of metal in ore. So this is called concentration of ore. Now, concentration of ore is divided into three terms, that is high reactive, medium reactive, and low reactive. High reactive, how you will concentrate? You will get the pure form electrolysis method. By electrolysis, we have discussed right now here in the container. Two electrodes are there, anode and the cathode. Anode attracts anion, cathode attracts cation. So in that way, that process is called electrolysis. By this method, you can get the pure metal. If the metal is a medium reactivity, and that is divided into two. If carbonate ore is there and the process is calcination, if sulfide ore is there, then the process is roasting. So for both the process, oxides of metal are there, and so oxides of ore, both you will get it. And by the reduction to the metal, we can collect the purified metal. This is the procedure, right? Understood? So metal of medium reactivity is there. The two forms are there, carbonate or sulfur. If carbonate is there, the process is calcination, and if sulfide ore is there, the roasting process is there. So for both, you can get the oxides of metal, and by reduction process, we can get the reduction to the metal, and then you will get the purification of the metal. If the metal is low reactive, then if the and that is of sulfide ore, again roasting and then metal and then refining process is there. This is the table you have to learn. So it will be easy if the metal reactivities you know, right? Potassium, sodium, calcium, magnesium, that one, and we can bifurcate that one. Now about the ores. Ore mined from the earth are usually contaminated with large amount of impurities such as soil and sand, and that is called gangue. The impurities must be removed from the ore prior to the extraction of the metal. The process used for removing the gangue from the ore are based on the difference between the physical or chemical properties of the gangue and the ore. Now, the extractions metal low in the reactivity series. Metals low in the activity series are very unreactive, like we have said right now. What ones that? Mercury, silver, gold. So the oxide of these metal can be reduced to the metal by heating only. So you have seen that if you are having a gold, any object is there. So if you want to take a pure form, so what you will do, if you are having a gold ornaments and you want to take the pure form, what you will do, there is a heating blast furnace is there, or we can heat that one, and then we can get the pure form of the gold. So by applying more heat, this is possible. Mercuric oxide is then reduced to the mercury and or further heating. So the example is given over here. Silver, sorry, this one is a mercury, HgS, mercury sulfide, applying with the heat applied in the presence of oxygen only. So 3O2, and balance this one, what we are getting, mercury oxide, HgO, and sulfur dioxide is released over here in the form of gas, and then this HgO again on heating you will get a pure form of mercury. And mercury you know very well, it's a metal, and only the exceptional case this is in the form of liquid. Yeah. So similarly, copper is found as a Cu2S in the nature. Cu2S plus oxygen gives Cu2O plus sulfur dioxide. This Cu2O again reacting with Cu2S, it gives sulfur dioxide, and pure form of copper you will get it. So this is how we are getting the pure form of the metal. Now extracting metal in the middle activity series. Before it was very low reactivity, and this one is a middle reactivity. So the process is roasting and calcination. We have studied in the mind map, or we can say chart classification. The metal in the middle of the activity series such as iron, zinc, lead, copper are the moderate reactivity. So sulfide ore are converted into oxides by heating strongly. So this is the sulfide ore, ZnS, reacting with the oxygen. Here you will write 3O2. Its missing is there because every time oxygen is in the form of 2 only, diatomic forms only. So what we will get, sulfur plus oxygen gives sulfur dioxide, SO2, and zinc oxide is there. Okay, this all equation you have to learn it. Now calcination. So calcination is which ore? Carbonate ore. So zinc carbonate, again on heating it gives zinc oxide and carbon dioxide is released. And again the second step is what? Zinc oxide plus carbon. When we are applying carbon as form of solid, zinc carbon monoxide is released, and zinc you will get in the form of pure form. This is the procedure. So metal oxide are then reduced to corresponding metal by using a suitable reducing agent, that is such as carbon. For example, zinc oxide is heated with a carbon, it reduces metallic zinc, and carbon monoxide gas is released. Next one is what? Extractions of metal with a high reactive. When it is a high reactive, what are the high reactive? Sodium, potassium, calcium, aluminum are the high reactive series, and that is extracted by the electrolysis reduction. So what you can see here at cathode, which type of cation will be there? Cathode attracts cation and anode attracts anion. So hydrogen and sodium both is there. Acha, this one is sodium, right? So sodium Na plus electrons gives Na, and 2Cl minus gives Cl2 plus 2 electrons. How you will know? Because chlorine is in the diatom molecules. So Cl is a C in the form of Cl2, and 2 electron is released. This one you have to learn it. Now extractions of aluminium, how we will start? The electronic configuration is 283. What is the valency? The outer shell, this one is the outer shell. The first orbit contains 2 electrons, second orbit contains 8 electrons, and the third orbit contains 3 electrons. Aluminum atomic number is 13. So we will write 283. First always 2, second orbit always 8, third orbit 8 is there, but you have to calculate. 2 plus 8 is 10, 10 plus 3 is 13. So 13 is there. So what is the valency here? Valency is 3. Aluminum is a reactive metal. Aluminum is extracted from the main ore, that is a bauxite. Right now we have discussed bauxite, that is what, Al2O3, and water. It contains 30 to 70% of aluminum oxide, that is Al2O3. This is bauxite, which is the hydrated form of aluminum, and which contains aluminum oxide, which form 30 to 70% of aluminum. Now aluminum is obtained by the electrolytic reduction of aluminum oxide, and the remaining proportion in the gang, that is what, sand, silica, SiO2, aluminum iron oxide, Fe2O3. So in exam they can ask what is the form of silica. Silica is SiO2. Okay. So as you can see here, this is the electrolysis form of aluminum. This is the extraction form. The down one is what? It's a cathode, and the upper one is what? It's a anode. Both are in the form of carbon. Carbon electrode is there, and here you are having a molten form of aluminum. So as you can see, the in the GIF, it shows what, that aluminum goes to the cathode and oxygen it goes to the anode. So this you can collect here, the pure form of aluminum, and aluminum is heavy, so it will settle down, and you can collect from the pure form of aluminum over here. Yes. Now refining of metal. The process of refining of impure metal is called refining of metal. Refining, the word you know, purified, right? So most common one is the electrolytic refining. So in the electronic refining by electrolysis, a thick block of impure metal is made anode. A thin strip of pure metal is this is made made cathode. A water soluble salt of metal is taken as a electrolyte. This is the process for the electrolysis. See here, refining of metal. How you will get? You can see here. This is the copper, impure copper. This one is a pure copper. The whatever impure copper is there, we are collecting from here, and it goes to here. This is a solution of a copper sulfate, CuSO4. Two electrode is there, which is one is impure copper, and the other one is a pure copper. So pure copper is what? Copper is Cu plus 2. So Cu plus 2, it attracts to the cathode. Cation, Cu is a cation. Cation attracts to the cathode. So in this way you can take, and you can see here, find the impure form of the copper, that is a anode mud is there. Okay, so this is how it works. The electron passes from here, and the cation goes from here to the cathode electron. Now the last topic is about the corrosion. You know what is corrosion, how it corrodes, and what are the reasons for the corrosion, and how to stop corrosion, right? So what are the things required for the corrosion? Oxygen and water is required. So for stopping the corrosion, what to do? Galvanizing, electrolysis, painting, oiling, greasing. Yes. So the loss of material, that is metal or alloy, or its useful properties by a chemical or electrochemical interaction with its environment is called corrosion. For example, rusting of iron, formation of a green layer on the copper surface. You have might be having a copper glass or copper utensils at home. We can see the layer, black layer or a green layer outside the copper. That is what actually a corrosion, right? It reacts with the oxygen, so it forms copper oxide. See here, the we have taken three test tubes. In that, three nail is there. One is applied with the water and air is there, and then we are closing with a cork. Here we have taken a boiled water. What is the difference between the normal water and the boiled water? Normal water, it consumes the oxygen, and in the boiled water there is a less amount of oxygen is present, and in that we are adding the oil also, so it will not comes in contact with the air. And the third one is what? Anhydrous calcium chloride. What is the formula of calcium chloride? It's a drying agent. It is CaCl2. CaCl2. Okay, so it absorbs all the moisture. Okay, so which one will rust? Obviously the test tube A, it will rust. Why? Because it is connected with the water as well as air. Here it will not form any rust over here because no oxygen or less oxygen is there, and oil prevents here to contact with the air, and here calcium chloride absorbs all the moisture. So here also no, in the test tube C there is no rust formation is there. Next topic is what? Silver article become a black. So when it is exposed to the air, it becomes black. So you have silver jewelry, right? Like anklets or bracelets you are having, or any glass you have at home. So it becomes black when it is exposed to the air. So this is because it reacts with sulfur in the air to form a coating of a silver sulfide. Copper reacts with a moist carbon dioxide in the air and slowly loses its shining brown surface and gains a green coat. So this green substance is copper carbonate. In exam it will come, what is the color? What is the color of copper carbonate? So it is green color. Or they can ask, what is the green layer it forms in the copper? That is a copper carbonate. Yes. Iron, when exposed to the moist air, it forms a long time, acquires a coating of a brown flaky substance. That is called rust. It takes maybe 6 months or a year for the coating of the brown flaky substance, and that is called rust. Rust. What is the formula of rust? Fe2O3. The formula of rust is iron oxide Fe2O3. Yes. Now, how to prevent? We have discussed right now: painting, oiling, greasing, galvanizing, chrome plating, analyzing, and making alloys. Also, galvanization is a method of protecting a steel and iron from rusting by coating them with a thin layer of a zinc. We are having a taps at home. It is not getting rusted. So, how to prevent it? How you will prevent it? That is by making a layer, making coating of chromium coating or a zinc coating. Yes. Fine. Thank you. Hope you understood the topic very well. You need to write all the textual exercise as well as index question in the classroom. Thank you.